Human space travel is the idea of people journeying beyond Earth's atmosphere. It's about leaving our home planet to explore the vast, dark emptiness of space. This isn't just about sending robots or probes, it's about putting human beings inside a spacecraft and sending them on a mission. The goal could be to orbit the Earth, to land on the Moon, or even to travel to other planets like Mars. It represents one of our species' greatest technological achievements. It pushes the boundaries of what we think is possible. This incredible feat requires complex machines, brilliant minds, and a tremendous amount of courage from the astronauts who make the journey. For centuries, long before we had the technology, people looked up at the night sky and dreamed. They saw the moon, the planets, and the distant stars, and they imagined what it would be like to visit them. These dreams were captured in stories, myths, and early science fiction. Think of ancient myths about gods traveling through the heavens, or later stories from writers like Jules Verne, who imagined firing a cannon to send people to the moon. These weren't scientific plans, of course. They were expressions of a deep and fundamental human curiosity. They planted a seed in our collective imagination, a powerful idea that we didn't have to be stuck on the ground forever. This imaginative phase was incredibly important. It inspired generations of thinkers, scientists, and engineers. The dream of spaceflight wasn't just a fantasy, it was a challenge. People started asking serious questions. How could we escape Earth's gravity? What would a person need to survive in the vacuum of space? Early pioneers like Konstantin Tsiolkovsky in Russia and Robert Goddard in the United States began working on the science. They developed the fundamental principles of rocketry. They understood that to go to space, we needed to use powerful engines that could push a vehicle fast enough to break free from our planet's pull. The transition from dream to reality was slow but steady. It required moving beyond stories and into the world of mathematics, physics, and engineering. The basic concept that emerged was the multi-stage rocket. This was the key idea that would eventually unlock the door to space. Instead of one giant explosion, a rocket would use several smaller engines, or stages, that would fire in sequence. Each stage would lift the spacecraft higher and faster, then drop away, making the vehicle lighter. This was the theoretical foundation that would eventually allow us to build the magnificent machines capable of carrying humans into the cosmos, turning our oldest dreams into a tangible, breathtaking reality. The real race to space began in the mid-20th century. This period was heavily influenced by a competition between two global superpowers, the United States and the Soviet Union. This space race accelerated progress at an unbelievable rate. The first major breakthrough came in 1957, when the Soviet Union launched Sputnik 1, the world's first artificial satellite. It was just a small, beeping metal sphere, but its journey around the Earth sent a powerful message. It proved that leaving our planet was possible. This event spurred the world into action, creating a focused, well-funded effort to not just send machines, but also people, into the great unknown that lay beyond our atmosphere. Following Sputnik's success, both nations worked tirelessly to achieve the next monumental goal, putting a human in space. The Soviets once again achieved a historic first. On April 12, 1961, a cosmonaut named Yuri Gagarin climbed into his Vostok 1 capsule. He launched into the sky and completed a full orbit of the Earth before returning safely. His famous words, "Poyakali, let's go," marked the moment humanity officially entered the space age. Gagarin's 108-minute flight was a triumph of engineering and human bravery. It proved that a person could survive the powerful forces of launch, the weightlessness of orbit, and the fiery heat of re-entry. The United States was quick to respond to this incredible achievement. Less than a month later, on May 5, 1961, astronaut Alan Shepard became the first American in space. His Freedom 7 capsule didn't go into full orbit like Gagarin's, but it was a crucial step forward for the American space program, known as NASA. These early missions were incredibly risky. The technology was brand new, and the astronauts were true test pilots, venturing into an environment we knew very little about. Every single flight taught us something new about the spacecraft, the effects of space on the human body, and the procedures needed to ensure a safe mission. These initial steps paved the way for even more ambitious goals. The ultimate prize of the space race was the moon. This led to the Apollo program in the United States. After years of development, countless tests, and immense dedication from hundreds of thousands of people, the goal was achieved. On July 20th, 1969, the Apollo 11 mission successfully landed astronauts Neil Armstrong and Buzz Aldrin on the lunar surface. Armstrong's first step, and his words, "That's one small step for a man, one giant leap for mankind," became an iconic moment in human history. It was the culmination of a decade of intense effort, forever changing our relationship with the cosmos. After the excitement of the moon landings, human space travel entered a new phase. It became less about winning a race, and more about learning to live and work in space for longer periods. This led to the development of space stations. These are large laboratories that orbit the Earth, where astronauts can live for months at a time. The first ones were the Soviet Salyut stations and the American Skylab. These early outposts taught us a great deal about how the human body adapts to long-duration weightlessness. They were the proving grounds for the life support systems, recycling technologies, and daily routines that are essential for a permanent human presence in orbit. Today, the most important example of this is the International Space Station, or ISS. It's a remarkable achievement not just of technology, but of global cooperation. Countries that were once rivals in the space race, including the United States, Russia, Europe, Japan, and Canada, came together to build and operate this incredible facility. The ISS is a floating science laboratory that has been continuously inhabited by astronauts since the year 2000. On board, crews conduct thousands of experiments in biology, physics, astronomy, and medicine. These experiments help us understand our world better and prepare for future, longer journeys into deep space. Beyond the ISS, space travel today is vital for our modern lives on Earth, often in ways we don't even notice. A huge part of this involves satellites. These machines orbit our planet and perform critical functions. GPS satellites provide the navigation that we use in our cars and on our phones every single day. Weather satellites monitor cloud patterns and storms, allowing us to predict the weather with amazing accuracy and save lives by warning of dangerous hurricanes or tornadoes. Communication satellites relay television signals, phone calls, and internet data all across the globe, connecting people from even the most remote corners of the world. Furthermore, we continue to send robotic explorers to learn about our solar system. Missions like the Mars rovers, which are like robotic geologists, drive across the Martian surface, sending back stunning pictures and analyzing rocks to search for signs of past life. We have sent probes to fly by Jupiter, orbit Saturn, and even land on comets. While these are not human missions, they are a direct extension of our drive to explore. They gather crucial data that helps us understand the origins of our solar system and identify potential future destinations for human explorers. These robotic missions are the scouts that map out the territory for the human pioneers who will follow. Looking ahead, the future of human space travel is filled with exciting possibilities. The next major destination on our map is Mars. Returning humans to the moon is seen as a critical stepping stone for this goal. NASA's Artemis program aims to establish a sustainable human presence on and around the moon, including a lunar base and an orbiting station called the Gateway. This will allow us to test the technologies and practice the procedures we will need for a much longer and more complex mission to the Red Planet. A journey to Mars will take months, not days, and will require new types of spacecraft, advanced life support, and protection from deep space radiation. The landscape of space travel is also changing thanks to the rise of private companies. Companies like SpaceX and Blue Origin are developing their own reusable rockets and spacecraft. This innovation is making access to space cheaper and more frequent than ever before. Reusable rockets, which can land themselves back on Earth after a launch, dramatically lower the cost of putting things and people into orbit. This new commercial space industry is not only supporting government missions to the ISS, but is also opening the door to new possibilities like space tourism, where private citizens could one day buy a ticket to experience space for themselves. But why does all of this matter? Why should we continue to invest time, money, and resources into pushing farther into space? The reasons are numerous. Space exploration drives technological innovation. Things developed for space, like GPS, improved medical imaging, and fire-resistant materials, often find their way into our everyday lives, making them better and safer. Pushing the boundaries of what is possible inspires the next generation of scientists, engineers, and dreamers. It encourages young people to pursue careers in science and technology, which is vital for solving problems here on Earth. Ultimately, space travel is about the future of humanity. It speaks to our innate desire to explore, to learn, and to grow. As a species, facing challenges together on a global scale, like building the ISS, helps to unite us. Looking beyond our own planet gives us a unique perspective on Earth, often called the overview effect. Astronauts who see our world from space describe a profound sense of its beauty, its fragility, and the lack of visible borders. It reminds us that we are all crewmates on this one small, precious spaceship called Earth, and that our potential to achieve great things is truly limitless.